Southeast Asia. A deadly plague sweeps across the countryside. It kills almost half the people it infects. Amid the panic, a maverick investigator joins an international team to crack the mystery that threatens his country. It is April 1999, and an epidemic devastates rural Malaysia. The victims, pig farmers, are burning with fever, slipping into delirium, comas, and beyond. Entire villages empty in panic, as one household in 3 is hit by the disease. Pig farms are obliterated as the epidemic spirals out of control. Outbreak investigator Dr. Mike Bunning and an international team work around the clock to contain the killer.
We are always waiting like horses in a stable to go to the next outbreak. That's what we're there for. It was a dream from heaven for Epidemic Intelligence Service officers. It's what you want to do. It's why you get involved. It's why you're there.
Four months earlier, December 1998. The Ko family live in southern Malaysia, in a town called Sungai Nipah. Like most of the families here, pig farming is in their blood. Passed down from his father, Mr. Ko has run his farm for over 20 years. With 1,500 animals, work is tough but lucrative. There are 2.5 million pigs in this country, in an industry worth $250 million. But Mr. Ko fears for the future of his business. The pig farms of North Malaysia are battling a mysterious epidemic, killing both animals and farmers. If it moves to Sungai Nipah, from the outbreak farms of the north around Ipoh, it will be catastrophic. This farm in North Malaysia has been devastated by the epidemic. The farmer has died, and so has his son. His wife is selling these seemingly healthy pigs to a farm in Sungai Nipah, where the Ko family lives. They will unleash a biological firestorm, devastating the lives of thousands of people. Sungai Nipah wakes up to another normal day. But the air of normality is broken by shocking news. A local pig farmer falls sick, suffering the same symptoms as the northern outbreak. Within days, 8 more cases are reported. The outbreak is assumed to be Japanese encephalitis, endemic in rural Asia, with up to 50,000 cases a year. This often fatal virus is common in pigs. The villain behind Japanese encephalitis is the mosquito. The insects bite both pigs and humans, transferring the virus to people. Dr. Mike Bunning witnessed the outbreak symptoms firsthand.
The symptoms that we see in humans typically start off with a very mild headache, uncomfortable, dizzy sort of feeling, and then progress to a very severe headache and a debilitating mental disease from there, where there's encephalitis or an inflammation of the brain.
The response is to eradicate the mosquitoes. Farmers are vaccinated against the virus, But these measures seem to have no impact. The killer continues to spread unchecked. In Kuala Lumpur, pediatrician and amateur virologist Dr. Paul Chua watches the outbreak unfold. There are things about this epidemic that just don't add up. He is deeply concerned about the type of people afflicted. The victims of Japanese encephalitis, or JE for short, are usually younger.
In JE, normally the patients affected are mainly children. A lot of people succumb to illness, actually healthy adults.
But humans are not the only victims. The so-called Japanese encephalitis outbreak is killing pigs too.
Normally the JE virus don't make the pigs sick. And in this situation, there are pigs dying from the illness. So something is very unusual.
Yet the authorities seem complacent. No one questions the diagnosis of the outbreak as Japanese encephalitis.
I feel something very unusual. I have a strong sense not JE. So at that period, I already have a strong feeling it's something different, could be a new virus.
But in order to be certain, he must get his hands on a blood sample from a victim to analyze it. Within 2 weeks of the virus hitting Sungai Nipah, a total of 14 people are dead across Malaysia. The new outbreak in the south proves to be even more deadly than the one in the north. As the days pass, more and more cases fill the hospitals. Malaysia is now in the grip of one of the deadliest killers mankind has ever seen. Within hours, victims fall into a coma. Within days, nearly half are dead. Then the virus kills a close neighbor of the Ko family. Deeply worried, Mr. Ko makes a decision to protect his family. The next day, they pack their bags and flee to a village away from the outbreak. They are leaving behind them their home and their livelihood in a bid to escape the killer virus.
I was very scared and nervous because it was the first time I'd left our village. I was very anxious.
For the Kos, this will be their home until the outbreak in Sungai Nipah is over. Here they hope they will be safe from the killer virus. The story now dominates the Malaysian news.
Don't relent on the preventive.
And the mystery of how the virus spreads continues.
Because we don't know how this disease is going to proceed.
Although the Kos have sought refuge away from the outbreak, every day the farmer must leave the rented house and return to Sungai Nipah to feed the pigs. Still believing Japanese encephalitis is the killer, he applies insect repellent, dresses in long trousers, and wears a long-sleeve shirt to combat infected mosquitoes. But the protection is in vain. Unbeknown to anyone, the virus is being transmitted by contact with the pigs themselves, not mosquitoes. The buying and selling of animals between the farms of Sungai Nipah is commonplace, but this spreads the virus freely between the pigs. Now, the epidemic passes to Mr. Ko's farm. Every time he feeds the animals, he is in danger from the deadly, unseen microbes. It is March 1999, nearly 6 months into the outbreak. After weeks of nagging the authorities, Dr. Chua receives blood and tissue samples from a victim of the outbreak. Now the amateur virologist turns detective. Convinced the killer is not Japanese encephalitis, he wants to eliminate it from his inquiry. He tests the sample for antibodies against the virus, but when the results are analyzed, they are positive. At first, Chua is puzzled. Could his hunch be wrong? Is this an outbreak of Japanese encephalitis after all? Quickly he realizes what the explanation is. The sample could have come from a patient who had been vaccinated against Japanese encephalitis. The antibodies may have been generated by the inoculation. Chua investigates further. This decision puts him on course for a crucial breakthrough, one which will gain him the esteem of virologists around the globe, like Dr. John Epstein.
Dr. Chua was astute in realizing that there were some things that weren't quite right about the outbreak, and that drove him to look further into it and to think about what else this could be besides Japanese encephalitis.
Next, Chua tests the effect of the virus on cultured cells. Soon the virus begins attacking them. Then, he makes an astonishing discovery. Cells begin fusing together into ugly masses, all infected with the virus and ceasing to function properly.
I was actually very nervous and excited. I knew I got something which I had never seen before.
This fusing together of cell membranes by the virus is something that Japanese encephalitis is not known to do. This is more evidence that the killer is not JE. Encouraged, Chua experiments further.
Following day, there are 2 more samples show the same changes, and in fact, I'm more worried that something really serious.
Chua's follow-up tests show something even more alarming. The fusing of cells was sinister enough. Now, infected cells are dying en masse. This proves the virus behaves entirely differently to Japanese encephalitis. But what is it? Could it be a virus unseen before? Now Chua reaches the limit of his tests. He's tried everything, and still the identity of the virus eludes him. A terrible sinking feeling takes over.
I really sympathize those people dying from the illness. I try to push to get people to understand we're dealing with really something very deadly and very different.
Mr. Ko believes he has done all he can to avoid the virus. But like thousands of others, he makes a fatal mistake in believing it's spread by mosquitoes. The deadly microbes replicate wildly inside the pig's respiratory system. The infected animal spreads contaminated mucus around the pen. As Mr. Ko walks through the pigs, mucus settles on his clothes. The virus is about to enter his system. Sungai Nipa is in a state of emergency as troops enter the village. At stake are the lives of thousands of people and the multi-million-dollar pig farming industry. The only way the virus will be beaten is by understanding what it is and where it has come from. But Dr. Chua doesn't have access to facilities for identifying new pathogens.
I was actually very upset how to actually identify this virus. So the best way actually is to try to get international help.
Chua calls the CDC. The Centers for Disease Control in Atlanta, Georgia, is a U.S. agency committed to protecting world health. CDC scientists are highly specialized in fighting rare killer viruses. Head of special pathogens is Dr. Tom Kizak.
Often we become involved in discovery of new disease agents when there are outbreaks.
But in Malaysia, Dr. Chua faces another hurdle in his battle against the unknown virus. How to transport the samples of infected blood and tissue 10,000 miles to the CDC.
Good afternoon. I'd like to book a courier to take a medical sample to the US.
Okay, medical sample, what is it?
It's actually a virus for analysis. It could be very securely packed. In fact, the container can withstand an air crash. And to keep it cool, it is surrounded by dry ice.
Dry ice is a problem, sir. We can't carry dry ice using our service.
Unsurprisingly, he is unable to find a courier willing to transport his deadly virus. This leaves him one choice: to take it himself. The infected human tissue samples are carefully packed into an airtight metal capsule, kept cool in dry ice. But there's another problem. Chua doesn't have a US visa. The amateur virologist's fears are now being taken more seriously by the government. An urgent intervention by Malaysia's health minister ensures he can travel to Atlanta.
Within 24 hours, I was given 10 years US visa to carry the sample over there.
In Sungai Nipah, Mr. Ko prepares to return to his temporary new home after feeding the pigs. Before leaving, he takes every precaution to protect himself and his family from the epidemic by washing thoroughly with disinfectant. But it's too late. He has contracted the virus. For days, it has been multiplying inside his lungs. The virus enters healthy cells and uses them to vigorously replicate. These replicated viruses, in turn, attack more cells in a chain reaction. The infection spreads to the blood, then to the brain. Damaged cells clump together, restricting blood flow and killing nerve cells. Desperately sick, he is rushed into hospital. The laboratories at the CDC, Atlanta, are among the most advanced in the world. Unlike Chua's facilities in Kuala Lumpur, they are what are known as biosafety labs, capable of handling level 4 viruses.
When you get up to biosafety level 4, which is the highest level of security, that's when you're dealing with a controlled, pressurized setting where, airflow is controlled. People are working in spacesuits where they have airlines and nothing comes in and nothing goes out. This is the highest level of security where people generally work on research on agents that are infectious, usually lethal to people, and there's no vaccine or treatment or cure.
Chua enters the electron microscopy laboratory to analyze a section of the sample. Looking at the screen, he is gripped by fear.
I saw the structure of the virus. That is essentially the hallmark of paramyxovirus. When I saw that, I can feel a chilling feeling actually go down my spine.
Paramyxoviruses are a group of microbes including those causing mumps and measles. But Chua's fear is that viruses of this type are not spread by mosquitoes. They are spread by close contact with infected people or animals.
Paramyxoviruses depend on a certain density of population, and also they tend to be transmitted through respiratory secretions, sneezing or coughing, and just in general contact. So they quite often tend to involve the respiratory system, and on occasion they become neurological.
The CDC analyzed the RNA of the virus, its genetic fingerprint. What they find changes the course of the investigation. The virus terrorizing Malaysia is similar to one that struck Australia 5 years earlier, called Hendra.
The first indication that it was a virus related to Hendra was the staining of some spot slide, and they reacted with Hendra antibodies suggesting that this virus was related to Hendra, and that was surprising. It gave us sort of a feeling that we were making rapid progress in figuring out what this was.
The Hendra virus appeared from nowhere near Brisbane, Australia in 1994. A horse contracted a mystery illness, suffering from respiratory problems and a loss of coordination. Within 24 hours, it was dead. Soon other horses in the stable fell sick and died. But then events took a dramatic turn for the worse. A horse trainer fell sick with similar symptoms. Within days, he too was dead. What puzzled the scientists was there weren't any known illnesses that caused respiratory diseases in horses and humans. The Australian Animal Health Laboratory was put on the case to solve the mystery. Tissue samples from victims were taken to the biosafety laboratories in Geelong, Australia to be tested. Epidemiologist Dr. Hume Field worked on the case.
Within a week, our lab had identified that a virus was the cause, and within a few more days, the reference laboratory at Arles had identified that this was a new paramyxovirus, a previously unknown virus.
The newly discovered virus was named Hendra, after the suburb of Brisbane where it emerged. Lessons learned from the Hendra outbreak will be invaluable in solving the outbreak in Malaysia. But first, Dr. Paul Chua, discoverer of the new virus, must give it a name. He decides to call it Nipah, after the village where the virus was isolated. So the virus has a name, but still no cure. Mr. Coe fights for his life, struck down by the Nipah virus. His wife agonizes as his condition deteriorates.
I was very worried. How could I carry on with my life if he died, because our children are so young? I prayed to God for his recovery.
Worse, the outbreak shows no signs of abating. The 24th of March, 1999, 6 months since the first case, and the CDC enter the scene, hot on the trail of the Nipah virus. Dr. Tom Kaisak leads a team of outbreak investigators, including doctors, vets, and virologists. Their brief is clear: to stop the outbreak of Nipah and stamp it out forever.
At that time, it was, I think, pretty clear that the pigs were the source of it, but ultimately the virus undoubtedly came from someplace else.
Acting on Dr. Chua's discovery, the authorities finally react. Sungai Nipah is evacuated, and roadblocks are set up to stop all movement of pigs.
In my opinion, it was pandemonium in Malaysia. Nobody knew what they were dealing with. Nobody knew how bad it was. Everybody is coming out, and you're going in. And you have to wonder, why are you doing this?
Now the destruction of more than 20,000 animals is ordered. Mr. Pao was a farmer with over 1,000 pigs. He recalls the harrowing ordeal of the height of the outbreak.
When we came back, we saw the army shooting the pigs. They dug trenches to bury them. It was very brutal. The pigs were screaming.
As the human death toll in the south rises to 48, the authorities take even more drastic action. In a desperate bid to cleanse the village, infected farms are bulldozed to the ground. In total, 1 million pigs will die, sick or not, to curb the epidemic. Australia's Hendra outbreak of 1994 will provide clues to help solve this case. Joining the CDC team is Australian epidemiologist Dr. Peter Daniels.
After we received the information from CDC that a Hendra-like virus was involved in this Malaysian outbreak, we had a meeting here of senior scientific staff. It was decided to send a scientist, and that person ended up being me.
The assembled team set about confirming how humans contract the Nipah virus.
One of our goals initially was to try and tie this disease in pigs and the disease in humans together, sort of closing the loop.
On the ground, the investigators hunt for clues. Their first ports of call are infected farms. Mike Bunning witnessed firsthand the Nipah virus rampaging through the pig pens.
We want to get as much blood as we can from all of them, okay?
Wearing full protection, the team takes specimens from suspect animals to confirm the virus killing the pigs is identical to the virus killing humans.
Pigs aren't the easiest animals to bleed. They're big, they're bulky, and they don't listen to commands of any kind. So the way that we would take a blood sample is from the jugular vein on their neck. To do that, you had to put yourself at risk.
The test results confirm it is the same virus in both pigs and humans.
It was shown that the pig's respiratory system, the lungs and the airways, were a site of infection, and we were able to deduce that the virus would have been spread amongst pigs and from pigs to people by the pigs coughing up the infected droplets.
And it seems simply feeding the pigs is enough for farmers to contract the virus.
At feed time, the pigs were taking a lot of interest in this activity and standing up and waiting to be fed, and so these people were exposed to all the droplets and everything that were coughed up by the pigs, and that had a high risk of infection.
The first part of the mystery, how the virus passes from pigs to humans, is solved. But the scientists still don't know how the virus got into the pigs in the first place.
When you're dealing with an infectious disease outbreak, it's really important to understand why people are getting sick. And once you've determined, like in the case of Nipah virus, where people were getting sick from contact with infected pigs, you then have to understand, where did this outbreak start? What was the source of Nipah virus?
Mike Bunning and the team are tracking the virus to its source. Every morning, he visits hospitals getting information on new victims. Then he locates their farms and scours for clues. Here, workers are questioned, whilst their bewildered families look on.
What we started to do is to try to tease out the particularities of the disease, and we did that by interviewing farmers first.
Now, I know it's a difficult time for him. He's lost his farmer and all, but I really need to ask him some questions. Is it okay?
是这样的，我们知道这个时期你们是非常困难的，但是我们需要你一点的宝贵的资料来协助我们。有问题吗？
And we would ask them, what did they see? What did they hear? And we would take those reports and take the different teams and bring them together.
50. We got 50 了 About 50? Yeah. Okay. Does he know where they came?
Together, a picture started to develop about the disease in pigs. That on day 1, they would see pigs ill, and maybe day 2, 3, or 4, they would start to see humans get ill. And that's where we started to tease out what was going on.
Somehow we've had the pigs transport from here to here because they didn't stop to here, right?
Piecing together information from infected farms leads Bunning back to where the virus began 6 months earlier.
Does it have some outbreak here? Yes. We're down here someplace.
The investigation team hope that when they find the scene of the first case, there will be clues as to how the Nipah virus entered the pigs. Mr. Coe, having contracted Nipah from his pigs, is desperately ill. 2 days, he battles fever and delirium. Convinced he has no hope of recovery, he discharges himself to return home to see his family one last time.
老婆，我回来了。
你为什么会回来呀？你不是还在医院的吗？你的病还没有好的啊！啊！
你坐下，我有很多事情要告诉你。哦，不可能迟些，我不能够回答你的问题了。
你不要这么说，你一定会好起来的。
这个农场是我们的主业。 我们不能够失去他，我们要守着他。我要他留给我的子子孙孙。
好，我答应你。无论发生什么。
Mr. Coe says goodbye to his family and returns to the hospital. The Coe family are in danger of losing everything: their farm, their pigs, their business. Even worse, Mr. Coe is in the grip of a virus with no cure. Slowly his vision blurs and he falls into a coma. The doctors can do no more for him. Seven months into the epidemic, and the international team slowly bring the virus under control. New cases of Nipah tail off as they restrict human contact with pigs. Bunning's investigation to find the origin of the outbreak begins to pay off. The trail of evidence leads them to a farm in the north of Malaysia, near the city of Ipoh. Here, there may be clues as to what animal passed the virus to the pigs in the first place, triggering the outbreak. The reservoir, as it's known, is the animal in which the virus lives and multiplies without making its host sick. 5 years earlier, epidemiologist Dr. Hume Field helped find the reservoir of the Hendra virus.
Finding the reservoir of an emerging disease really is a piece of detective work. Where do you start? What animals do you look at? What location do you look at? How many animals do you have to look at before you can be confident that if you're not finding it, that it's not there, rather than you just haven't looked at enough animals?
Looking for the reservoir can be like searching for a needle in a haystack. Some diseases have defied scientists for decades. For instance, epidemiologists still have no idea where Ebola came from, and that disease emerged in 1976. Field's experience from Hendra will now prove invaluable. In the Australian Hendra outbreak, scientists tested every animal they could to determine the reservoir of the virus. Every time they drew a blank, until they discovered that there had been 2 almost simultaneous outbreaks 800 kilometers apart.
So it made us think that there was a host that could be virtually in 2 places at once. What kinds of animals could do this?
It seems that there wasn't just one outbreak of the Hendra virus, there were in fact 2.
Field called together scientists from a whole range of disciplines to pool their knowledge in a think tank.
The think tank was really useful in helping us gather our thoughts on the host and on the possible reservoir host.
Mammals are the usual host of paramyxoviruses. But what mammal could travel 800 kilometers in such a short amount of time? This puzzled the scientists for a while. But then came a breakthrough. Could it be a flying mammal? A bat. The investigators set out to test fruit bats in the Brisbane area. Sure enough, bats were the reservoir of the Hendra virus.
We were beginning to think that perhaps, in fact, we weren't going to find this the host of this virus after all, and then bang, it was quite remarkable.
With this knowledge, Field's team set out to find the reservoir of the Nipah virus in Malaysia.
While we realised we had to keep an open mind about the origins of Nipah virus, because it was so like Hendra virus and because Hendra virus was so different to any other viruses, we really did focus on bats.
Okay. So this is the mark they've used, Kareem, here? Yeah, cool.
With a wingspan of up to 5 feet, the Malayan flying fox is the largest bat species in the world. But in order to test them, they must be captured. And that's not easy.
Yes, nice one, guys.
Dr. John Epstein of the Consortium for Conservation Medicine is an expert in bat catching.
The flying foxes that we're interested in catching roost in trees that are typically very high off the ground. So the only way to capture them is to be able to get our nets up that high. We get the poles right up to the roost, and when the bats fly out at sunset, which is when they normally leave the roost to feed, they fly into our net, provided that it's dark enough that they can't actually see the net.
Now the bat catchers wait for dark. Once a bat is snared, the net is lowered. Then it is carefully untangled and anaesthetized. Now the delicate task of testing for the Nipah virus begins.
The kinds of samples we take are blood samples so that we can see whether these bats have actually been exposed to Nipah virus. So we look for antibodies to Nipah virus. And then we swab both the mouth and the urinary tract.
Over 300 bats are caught, tested, and then released. The results are startling. In 20, antibodies to the Nipah virus are found. This means they have been exposed to Nipah and survived. So the virus thrives in the bat system without harming it. This is a major breakthrough. It means fruit bats are a reservoir of the Nipah virus. After 7 months and nearly 100 deaths, the Nipah case is almost solved. But there are still questions to be answered, like how did the bats pass the virus on to the pigs? To solve this mystery, the outbreak investigators must visit the so-called Index Farm, the place where the first case of Nipah was found. Here, they search for the link between bats and pigs. By the now deserted pig pens, the investigators find a possible clue. Fruit trees.
Many of the farms plant fruit trees around their piggeries as a second enterprise. So they farm pigs and also they grow fruit.
And in these fruit trees are fruit bats. Now the scientists need a theory for how the virus transmitted from the bats to the pigs. The man who discovered the Nipah virus, Dr. Paul Chua, gets onto the case. In the trees around the farm, he watches the bats chewing on fruit and then dropping it, covered in saliva, onto the ground below. Some of it falls into the pens. Dr. Chua swabs pieces of fruit dropped by the bats. Remarkably, he is able to isolate the Nipah virus on the fruit. So fruit is the missing link between the pigs and the bats. Infected bat saliva enters the pigs, infects the lung cells, and replicates within them.
The way the pig farm was situated among the orchard and the way the pig sty was constructed, that provide an avenue for the contaminated fruits, either by the saliva of the flying foxes or urine, drop into the pig style, and then the virus subsequently transmitted to the pigs.
The answer to how Nipah emerged, seemingly from nowhere, is important to scientists like Dr. John Epstein to prevent it ever occurring again.
One of the things we know is that Nipah virus has been in bats for a very long time. So it's something about the way humans have altered the environment, the way that humans have changed farming practices, the way we use land, how we've somehow disrupted the natural ecological behavior of these bats that probably led to the emergence of Nipah virus.
Intensive pig farming in the Ipoh area of northern Malaysia, in rainforest where fruit bats roost, might just be the ideal setting for the Nipah virus to jump from bats into pigs.
So it's human activities that really allow for a disease like Nipah to jump from bats into pigs.
Now, just one piece of the jigsaw is missing. There are no fruit bats in the Sungai Nipah area of southern Malaysia. So how did the virus first spread from the north to the south?
It's like doing a crime investigation. You go through lots of records, you take histories, and you try to trace back step by step how the virus moved from the north to the south. And it's very difficult because the records aren't always there.
First of all, is she okay speaking here? Because if she's not, she can
Then,
tell.
one night in Ipoh, northern Malaysia, something happens that changes the course of the investigation. A farmer's wife secretly approaches the outbreak team with a startling new piece of information.
At first, I didn't really understand the risk she was taking by coming to talk with us. And it was very clandestine, and it ended up being in a coffee shop.
She sets about telling Bunning her tragic story. Early on in the outbreak, she had lost both her husband and son in the space of a few days to the then mystery virus.
I'm sorry to hear that. I'm sorry. Go on.
And when that happened, she decided right then that she was done with pig farming. And so what she did is she put out the word and she sold her pigs overnight throughout Malaysia at a reduced cost.
She say because of the financial problem, she sell the pig very, very cheap to the south part already. Maybe they will spread the virus already like that.
She confesses that many of her pigs were sold to villages like Sungai Nipah in South Malaysia.
During the course of that meeting, she identified how the disease was moved from the northern part of Malaysia where it started, in Ipoh, to the southern part where we were seeing so many human cases and so much disease.
It seems likely that it was this and a similar movement of infected pigs from the north to the densely populated pig farms of the south that triggered the spreading of the outbreak. For 3 days, Mr. Coe is deep in a coma, battling the Nipah virus. It seems there is little chance of recovering. The virus moves through his body to the brain, where it attacks and kills nerve cells. But Mr. Coe defies the odds and regains consciousness.
When I woke up, my memory was hazy. I could remember certain things, but not everything. It was like a partially erased cassette tape.
He slowly regains his strength and returns home. 8 months after the start of the outbreak, Sungai Nipah is free of the virus. But the village now resembles a battle site.
The next day, I rode my motorbike around the village. I saw the old pig pens in total disarray. It looked like a war zone. I was very upset at what I saw. It was very painful, but we need to be strong.
When he came back, he was very weak. He had a bad memory. But I felt happy he was finally home.
Today, there are no pig farms in Sungai Nipah, but the ruins of deserted pens are everywhere. For Mr. Powell, they are a painful reminder of those events in 1999.
Here we have the remains of some of the bones. It looks like they belong to the boars. This is a pig's skull bone.
Like most villagers, he has had to adapt to life without pig farming. But that is not the end of the story. The deadly Nipah virus is still out there, and still there is no cure. Since the Malaysian outbreak of 1999, the virus has struck 5 times in Bangladesh, killing over 80 people. Even more terrifying, the virus appears to have mutated.
And what's really interesting about Bangladesh is, in the outbreaks that have been investigated, it seems that there hasn't been an animal intermediate involved. In other words, there's no pig or other domestic animal that seems to be spreading the virus into humans. We've got clues that suggest that Nipah virus is spreading from human to human, and that raises all kinds of alarms.
Nipah is an ever-present danger. Today we can travel across the globe in less than 24 hours, giving viruses the means to move vast geographical distances very quickly. With Nipah mutating and capable of being transmitted between humans, the danger of a new global pandemic is a very real possibility.